So we're going to take a look at learning goal 31, which is all about solving linear inequalities. Now we're going to be looking at it algebraically, so it's similar to linear equations. There's a lot of similarities there, and we're going to be looking at that. We're also going to start by looking at what is an inequality, and we're going to go through some of the basics of that too, and how to describe an inequality as well. So let's just go back to equalities, or these might also be considered to be equations. In an equation, each side is equal to the other. Okay, so we have an equal sign, okay, that represents that fact. Right. So the equal sign represents that both sides are equal to each other. Now, when solving a linear equation, there is always only one solution, okay, to each problem. So if we look at any type of question, okay, there's going to be one individual solution, one example that is correct. Everything else is not correct. So there's one unique solution. So if we look at this question here, we're going to solve this equation. I'm going to go through it nice and quickly as we've done this in the past. To solve this, we're going to add 4 to both sides. Again, we've done this in the past. We want to get x all by itself. And so this is going to give us, okay, negative 3 plus 4 is going to be 1. Let's make it into an equation here. 1 is equal to 1 over 3x. There we go. So we have our equation. We're trying to get it, we're trying to isolate our x value. We're going to multiply both sides by 3. And when we do that, that's going to get x all by itself. See if we can get it up here. So 1 times 3 is 3, and 1/3 times 3 is just 1, so that cancels out. So x is equal to 3. This is our one unique solution to this question here. Now, while a singular value, let's do a different color here quick. A singular value is very useful. Okay? It's often needed. We often need just a single value that works. Okay? Many of the things that we have in life are not so cut and dry. And not everything is so cut and dry. Sometimes we do have a very exact answer. Sometimes things are much more called loose. So I'm going to take a look at 4 signs that you might see somewhere. Okay, the first one here is a speed sign. A speed sign says what is the maximum speed you're allowed to go on the highway. Okay, anything over is illegal. Okay, I'm not saying people don't do it, but I'm saying it is illegal. So that tells you that you can go 100 kilometers per hour down this highway. Now, if you're traveling at 95 kilometers per hour, it's not 100, but that's allowed because this is the max. Okay? Here's a sign that you need to be over this height to be able to ride on a ride. Okay, you may have seen this if you've been to an amusement park. Okay? You don't have to be exactly this height, you have to be over that height or more. So me, I'm probably over that height because normally they're made for children, and I'm a little bit taller than most children. I would be tall enough to go on this, even though I'm not exactly this height, I'm above. Okay, so I'm above. Here's another one. Supposed to store this at room temperature not exceeding 30 degrees. So I can have it at 20 degrees or 22 degrees, but I should not have it over 30 degrees. A video rating that you may have seen, it's 14A. Okay? That tells you that that video is recommended for people that are 14 and older. Okay? You can be older than 14 and still watch this video. It's not something that is, it's not an exact value. Now, none of these signs deal with an exact value. There is some leeway, okay, in what is or is not allowed. And we do the same thing in math, okay? And math is exactly just describing our world as best as we can. In math, we have questions, inequalities, that deal with all sorts of leeway that could happen. Or, we could have a bunch of different answers. Sometimes we have limits on both sides, and we'll talk about when that comes into play as well. So these are inequalities. When a wide range of values are possible as an answer, an inequality can be used to represent. Okay, it can be used to represent exactly that. These inequalities will always have an upper, lower, or both limits, which will be defined. Right? So they will always be defined. Now, if we look at these signs here, I'm just going to describe the limits of these signs. If we were doing this in class, we would go through and we would do it all together. Okay. In the first one here, we'll just take a look at the first one. Okay. Maximum speed of 100 kilometers per hour. Could go lower. Okay, there we go. There's our speed. Okay. So the speed needs to be less than or equal to 100. Okay, this next one here, the height must be greater than the limit. Okay, and the limit that we're mentioning here is this, cannot be shorter than that limit. Okay, this next one here, okay, we need to store at temperatures below 30 degrees. Okay, below 30 degrees. Okay, movie is recommended for people 14 and older. Oh, not 154, 14 and older. Okay. So this is what these signs are telling us. This is the general knowledge of it. Okay. And so when it comes to inequalities, we need to make sure that we recognize that it represents a large range. Okay. At 35, I'm allowed to watch a video that's 14.8 because I'm older than 14. Okay. I can drive 95 kilometers an hour because it is less than 100. I can go on this ride because I am greater than this height. I can store this in my house when it's equal to 21 degrees, okay, because it's less than 30 degrees. That is an inequality. That's what an inequality represents.